Chapter 6, Trigonometry, Lesson 3, Solving Trigonometric Equations. In this lesson, we will be solving some trigonometric equations, making use of some of the new information that you have learnt about reciprocal and inverse trigonometric functions. It is up to you as to whether you follow each part of this lesson with the video and work through the equations with me, or if you have a go at the equations yourself and then check the answers using the video. So we've been doing a lot of work about radians recently, and most of the work that we have done is in radians, but we could still be asked to work in degrees in a question. That's perfectly valid and feasible. So let's take a look at an example in degrees. We are going to solve sec theta equals 2 for angles between 0 and 360 degrees. So let's remind ourselves that sec theta means 1 over cos theta. So 1 over cos theta equals 2, which tells me that cos theta is equal to a half. So I can then work out my value of theta. Now, we're used to writing cos minus 1 of a half, but you can also, if you wish, write theta equals arc cos of a half. It's entirely up to you. It doesn't matter which version you use, as long as you know how to make sure you can do the calculation either in your head, if you've memorised your special trigonometric triangles, or on a calculator. It's worth mentioning these special trigonometric triangles just for a minute. So we know that we would have, in this particular triangle, 30, 60 and 90, 1, 2 and root 3, and then you can hopefully see that cos of 60 is equal to a half, so arc cos of a half is 60 degrees. Or you can do the calculation on your calculator. Don't forget to always check which mode you're in on your graphical calculator, and you must be able to toggle between degrees and radians. So remember, it's shift and then the menu button, which takes you to the setup option, and then scroll down to angle and then use F1, F2 to toggle between degrees or radians, depending on which you want. Now, of course, we're working in degrees in this question, so arc cos of a half will give us, if we input it into our calculator, 60 degrees, as expected from the special triangle here. So theta equals 60 degrees. Now, I'm going to solve the equations in this video using the trigonometric graphs. If you want to use the unit circle, the cast diagram, or the quadrants to solve the equations, entirely up to you. Use whichever method you are comfortable with and which gets you to the correct answers. So here's a sketch of y equals cos x, and I'm going to draw my horizontal line across for y equals 0.5, and then let's take a look at the 2 points of intersection carefully. And of course we know we've got one at 60 degrees, and then here's the other point of intersection there, and we're going to use the symmetry of the graph to find the other answer. So the second answer, theta equals 360, subtract 60, which is 300 degrees as the second answer. Always check on your calculator, cos 300, input it. It takes you 1 second to actually check the angles that you've got, and if you've made a mistake, you can then go back and correct it. So let's take a look at the second question. We're back to working in radians. Solve cosec 2 theta equals root 2. Now, cosec, of course, means 1 over sine. So this tells me that 1 over sine 2 theta equals root 2. So sine 2 theta is equal to 1 over root 2. So it becomes a much simpler equation to work with when we convert back to trig functions rather than the reciprocals. Sine 2 theta equals 1 over root 2. Now, this is automatically going to be a trickier equation because we're working with 2 theta here rather than theta. So first step is to write down that 2 theta will equal sine to the minus 1, or if you like, arc sine of 1 over root 2. And we're working in radians, remember, so if you're going to use your calculator rather than the special triangles to take the inverse sign here, make sure it's set in radians mode, otherwise you're going to get the wrong answer. And you should find you get pi by 4. And of course we could divide by 2 to get me the value of theta as pi by 8, but I'm actually not going to do that because we need to work in terms of 2 theta to get all our answers and then divide by theta at the end. Remember, the fact that we have 2 theta here means we will have double the number of answers for the given range 0 to 2 pi. So again, I'm going to use the sine graph to find my answers, so I will sketch this. So here's the graph of y equals sine x, a quick sketch in blue, and 1 over root 2 is a positive value. It's about 0.7-ish, so I'll draw a horizontal line here to help me find my values of 2 theta. So there is y equals 1 over root 2, and instantly we can see an intersection here and an intersection here. So remember, these intersections give us values of 2 theta, so 2 theta equals pi by 4, as we have over here. So I'm going to use the symmetry here to find this second value of 2 theta, and it's clear it's going to equal pi take away pi by 4. So the second value of 2 theta is 3/4 of pi. So I'm going to write that down here. 2 theta equals 3 pi by 4. And then I haven't sketched it here, but the whole thing is then going to repeat itself after 2 pi. So I'm then going to get 2 theta is equal to 2 pi plus pi by 4. And then 2 theta is going to equal 3 pi take away pi by 4. Just imagine what happens after 2 pi radians when the graph just repeats itself in exactly the same way, and effectively your 0 becomes 2 pi and your pi becomes 3 pi effectively. So the whole thing will just repeat itself after 2 pi radians. Again, if you're using the unit circle and the 4 quadrants, you're effectively going round the full circle to 2 pi and then going round again. Now, we must remember to divide by 2 to find all of our answers. So theta is equal to pi by 8, theta is equal to 3 pi by 8, and then theta is equal to 9 pi by 8, and theta is equal to 11 pi by 8. And here are our 4 answers. Now again, I would never dream of finalising my answers before checking them, so I would input all of these back into this equation here as values of theta to just double check that the answers are indeed correct. It takes 1 second to do that, and it could save you quite a few lost marks by checking your answers with your calculator. Alternatively, you can also draw the graph and use the intersections as we showed you earlier on your graphical calculator. It's another way of checking your answers. So let's take a look at example 3, another favourite of mine because people make some really silly mistakes on this. Sine theta minus 3 cos theta equals 0. Now, those of you who've done a lot of practice here will recognise this. You need to rearrange it. So sine theta equals 3 cos theta. And then remember, you can divide by cos theta because you're not getting rid of it. It's not vanishing. It's here in the denominator on the left-hand side. And you get this. And then, of course, you've got to remember that sine theta over cos theta is the same as tan theta. So you're using an identity here, which gives you tan theta equals 3. So you must remember that sine theta over cos theta is equivalent to tan theta. You've got to learn and remember these identities. So here we go. We can work out theta using arctan or tan to the minus 1. It's perfectly fine to write tan to the minus 1 of 3. So theta equals arctan of 3. Check your calculator is in radians here, as we're working between 0 and 2 pi, and theta equals 1.2490 ... Now remember, store that in a calculator memory. I'm going to round it to 3 significant figures for when I present my final answer. Now, I'm going to sketch the tan graph. Again, use whichever method you feel comfortable with when solving the equation, but you must show your working. slightly annoying here that my vertical scale doesn't actually allow me to show the value 3 here. So what I'm going to do, it's actually not really that relevant to have a vertical scale here for tan, because unlike sine and cosine, which are limited in their y values going up to 1 and -1, tan is not limited in its possible y values. So I'm going to just get rid of that scale here for the moment, because this is a sketch, it doesn't really matter too much, and I'm just going to draw in a line which is the line y equals 3, and we're just going to pretend that this is 3 here on the y-axis. It doesn't, as I say, really matter. It's much more about the symmetry of the graph here. So intersections, one of them is over here, and this is the value of 1.249 there. That's one value of theta. And here's the second value over here. And as I said, it's much more important that we understand how to actually use the symmetry of the graphs here than it is to draw them perfectly. So look at that gap there. That gap in purple is a length of 1.249 on the x-axis. And then look at that repetition there. It's exactly the same gap. So theta is then equal to pi, which is here, plus that purple gap here. So this value, theta, is pi plus 1.249. And remember to use your unrounded value, so the value you've stored in your calculator memory, and this then gives you a final answer of 4.390, etc. So to 3 significant figures, that's 4.39 radians. Now please use C or rads to indicate that your answer is in radians. Be clear. Now, example 4, a favourite equation of mine, 2 sine squared theta plus 3 sine theta minus 2 equals 0. Now, hopefully you can recognise straight away this has the format of a quadratic. And that means we can factorise or try and factorise, and if we can't factorise, we may have to use the quadratic formula to find the values of sine theta. This particular example will factorise. So my brackets, one of them is going to have to be 2 sine theta, the other one is going to have to be sine theta. Make sure you practice the factorisation yourselves. Don't just copy this down, that's too easy and you're not learning. Make sure you have a go at doing the factorisation yourself. And if you're a bit uncomfortable with starting with a trigonometric function for the factorisation, why don't you try factorising 2m squared plus 3m minus 2? And then going from there, where m represents sine theta, and that might help you work out your answers doing it that way. So what do I have in my factorisation? So I've started my brackets, 2 sine theta, and I'm going to need a 2 here, positive, and a -1 here, and there we have the correct factorisation. So from here, this gives me 2 options, sine theta equals 1/2, or from here, sine theta equals -2. Now you should know straight away that the second option here has no real solutions. Sine theta is capped between a value of -1 and 1. Think about the sine curve. And we're going to use the sine curve to solve the second equation. So first of all, theta equals arc sine of 1/2. And that gives me a value of pi by 6. And then I will sketch my trig graph. So have a look at the sketches of y equals 1/2 and y equals sine x. We can see we get an intersection here and an intersection here. And of course, this first answer is theta equals pi by 6, and then use the symmetry of the function here. That's pi by 6, this gap is pi by 6, so we can work out the second answer as theta equals pi minus pi by 6, so an answer of 5 pi by 6. So theta equals pi by 6 and theta equals 5 pi by 6 are our 2 answers between 0 and 2 pi. Now, next example, another classic question here. You notice there's a sine squared, like in the previous question, but there's also a cos theta here. So this means we need to use the identity sine squared theta plus cos squared theta is equivalent to 1, and you must learn that identity and make sure you know when you can use it. Now the identity tells me that sine squared theta is equivalent to 1 minus cos squared theta. So where I have sine squared theta here, I'm going to replace that with 1 minus cos squared theta. So this gives me 6 bracket 1 minus cos squared theta minus cos theta minus 5 equals 0. So simplifying here, this then gives me 6 cos squared theta plus cos theta minus 1 equals 0. Again, we've got to factorise this, and as I said previously, if you're feeling uncomfortable about factorising a quadratic type expression, then try factorising 6m squared plus m minus 1, and you have used m in place of cos theta here, which you need to remember when you're finishing off. Now again, don't copy my factorisation, try it yourself or use your calculator to find the answers and then work back to the factorisation. Either way, you will find that the brackets are going to begin 3 cos theta and 2 cos theta. There has to be a 1 and a 1, but one of them is going to be positive and one of them is going to be negative. And from here, we get two possibilities. One is that cos theta equals a third, and the other is that cos theta equals negative a half. Now, both of these are valid. Both of these will actually work. Let's see what we get. So the first one, when we use inverse cosine or arc cosine, gives us an answer of theta equals 1.2309. Store that in a calculator memory for safety for when we use that again. And I'm going to sketch the trigonometric graphs here of y equals cos x on the set of axes. So here's my graph of y equals cos x in blue, and here is a graph of y equals 1/3, and here is my first point of intersection there, which of course is this value, theta equals 1.23, etc. Now, from the symmetry of the trigonometric curve, the other answer, which is over here, is 2 pi subtract that value of theta. So I can work out my second value of theta here. Theta equals 2 pi minus 1.23, etc. And because we've stored it in a calculator memory, it's easy to access. And this gives me 5.0522. Now that's within range. Remember I suggested earlier on in a previous lesson, always know what your values of your angles are in decimals as well as multiples or fractions of pi. And remember, 2 pi is approximately 6.28, and so we know our answer of 5.05 is less than that. We also know that from the graph itself. So these are two values. We'll round them a little bit later on. Let's find out what we get from arc cos of negative 0.5, and we get an exact fraction of pi. We get 2/3 of pi. So what I'm going to do is just add to my graph a horizontal line to represent y equals negative 0.5. Here it is in purple. And let's find my two intersections. There's one over here and there's one over here as well. Now this first one is 2/3 of pi, and use the symmetry here and here. So I can calculate my second answer by doing 2 pi take away 2/3 of pi, which will give me 4/3 pi. So I have 4 answers. Theta equals 1.23 radians, theta equals 5.05 radians, theta equals 2/3 pi, theta equals 4/3 pi. And I don't really need to use the radian symbol for the third and fourth answers here because they're in terms of pi. And I'm then Now, my final example is very similar. Have a look at what we have here. 2 sec squared theta equals 7 tan theta minus 1. Now, you need to become absolute experts at spotting the connection between sec and tan, because of course we learnt 2 new identities, and one of those new identities tells us that 1 plus tan squared theta is equivalent to sec squared theta. So this tells me that I can replace sec squared theta with 1 plus tan squared theta. And you need to spot the connection between sec and tan. It's a very, very common sort of question. Now, expanding the brackets and simplifying and rearranging will take me to 2 tan squared theta minus 7 tan theta plus 3 equals 0. And again, we've got to try and factorise this. And I've given you some tips previously if you're less comfortable with doing this. Remember, you can also try and use your calculator to help you with the factorisation by working backwards from the answers. You can also use the quadratic formula, and you might have to if you end up with an equation that doesn't factorise. This one does, and we end up with 2 tan theta here, 3 and 1 and both negative here. So what do we have as possibilities? We have tan theta equals 1/2, and the other option is that tan theta equals 3. And we're going to use inverse tan and sketch the graphs to solve these. So let's start with tan theta equals 1/2. So theta is going to equal arctan of 1/2. Now, that is not going to be an exact value of exact fraction or multiple of pi. It's going to be 0.4636. Again, let's store it in a calculator memory, and let's draw it on our graph here. So you can see I've got the sketch of the tan graph in blue with the asymptotes as well, and the graph of y equals 0.5. So here's my intersection, 0.4636 here, my first value of theta, and I can use the fact that this purple distance here is the same as this purple distance here to work out my second value here, which is theta, which is pi plus 0.463. So theta also equals pi plus 0.463, which comes to an answer of 3.6052, etc. Now, the second equation, tan theta equals 3, we actually solved this in a previous example, so I'm not going to repeat the working for that. I'm just going to write down the answers we got. If you feel it would be useful for you to work those out again, please do. And I'm then just going to include the last 2 answers here, rounded, so that's 0.464 radians and 3.61 radians, all rounded to 3 significant figures. And don't forget, the final opportunity to check that your answers are correct, substitute them back into the original equation up over here to check that they do actually work, or use your graphical calculator to check your answers.